Okay, there are 5 equations that are given in the formula book, but you know me, I don't like memorizing formulas, and I don't think, well, it's in the book, so I don't need to know it, is an adequate excuse. So let's derive them so that we don't need to memorize. First, let's draw a velocity time graph. A velocity time graph looks something like this, right? Where this is velocity, this is time, t, right? We start at initial velocity, u, right? We go up, right? And after t amount of seconds, right? We have velocity v. What do we know about velocity time graphs? We know that if v is a function of time, right? We know that acceleration is the gradient function of time. Okay? So what's the gradient of this line going to be? The acceleration a is going to be the change in v over the change in t, which is the same as v minus u, okay, I'm going to make that v look a bit better, over t. Yeah? And now I'm going to rearrange it just to make v the subject. This will make sense why in a couple steps, right? V minus u is equal to at. And so therefore v equals u plus at. Bow. And now you never need to memorize that equation again. You know how it works. On that same token, if v is a function of time, right, then the displacement is the integral of the function of time, also known as the area. What is the area of this function? The area S is equal to, well, let's take a look. It's a, what is it? It's a trapezium. So this is U, right? And this is V. And we know that this is T. What's the area of a trapezium? The area of a trapezium is a half A plus B times H, which is the same as a half V plus U times T. Yeah? No memorizing. You've just derived 2 of the formulas of constant acceleration. Does this video make sense? Well, make sure you subscribe so you never miss a video like it from me. Now let's look at those equations again. So S equals T over 2 times V plus U. Right? And we also know that V equals U plus AT. Okay? So what we're going to do is for each of these, we're going to make V and U respectively the subject. Okay? So first let's substitute U plus AT into V, right? S is going to equal T over 2 times U plus AT plus U. Okay? So if we simplify this, this is the same as T over 2 times, are you ready? 2U plus AT. Okay? And then we can expand the brackets again. And S will be equal to UT plus a half AT squared. And that is another formula down. Now let's do it the other way, okay? The other way round is where we make U the subject. if v equals u plus at, that means then that u is equal to it's going to be u is equal to v. You can do it the way that I just explained, but it's a bit better to do it the other way. It's going to be v minus 80. Okay? So now let's sub in that for u. Gonna use my purple pen. We're going to put v minus 80 here. So s is going to be t over 2 times v plus v minus 80. Yeah? All we've done is substituted that. Now let's add them up. So it's going to be t over 2 times 2v minus 80. And so s is equal to vt minus a half at squared. And that is 2 more equations down. Still not making any sense? Well, join my Discord server down below and ask me whatever questions you want for the 4 fast responses guaranteed. I did this in a different order than what I intended. That's fine. So it's not last 2 equations. It's just going to be the last equation. What do we know so far? We know that v equals u plus at. S equals t over 2 times u plus v. I'm going to make that u there. And then s equals ut plus a half at squared. And s equals vt minus a half at squared. Now, what do you notice about each of these equations? Each of these equations, like there are 5 variables, right? SUVAT, right? For each of these, you're eliminating one of these variables. So this one has no s, right? This one has no acceleration. This one has no final velocity. This one has no initial velocity. So this one has no u. We need a function without time. To do that, what we're going to do is use these 2 equations together again, right? And this time we're going to make t the subject. So if v equals u plus at, then that means that v minus u is equal to at. And so therefore v minus u over a is equal to t. Let's substitute that in to s equals t over 2 u plus v. So s is equal to v minus u over a times a half. I'm going to take the half out just for the sake of argument, right? And then we're timesing that by u plus v, okay? Now what we're going to do is take it out of the fraction. So we're going to times both sides by 2 and times both sides by a. So 2as is equal to v minus u, and we're timesing that by v plus u, okay? And what is this? This is a difference of 2 squares. So we can say that this is v squared minus u squared. And so our final equation without time is v squared is equal to u squared plus 2as. And that is your 5 SUVAT equations. No memorizing needed. Thank you guys for watching. I hope this video made sense. Do you guys want to pass your exams with flying colours? Well, you can get tutored by me. Drop me an email for a meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.